Okay, after we talk about the device and gateways in IoT, now let's come to another fundamental aspect of IoT. Basically, it is the networking. So we'll cover the most important knowledge you need to know about networking for IoT applications. But we are not networking engineers, so we won't go to very much details. Okay, so first of all, what is a network? So actually, believe or not, it's very simple. A network is created when two or more computing devices exchange data or information. So by definition, if we have only two devices and they try to connect with each other, we already found the most basic version of network. For illustration purpose, we use this example here. So we have three devices here, and we have some lines connecting them. With this illustration, such devices are known as nodes. So that's a terminology you need to know for network. And they communicate over links. So for links, usually we use the wires here, the lines. So nodes and links. So those are the two most basic network terminology. So for the nodes, it can be basically many things. It can be PC, servers, those kind of things. And the limitation or consideration for the nodes, including the computational, energy, memory, communication. Basically, it can be basic devices or advanced devices, right? For the network links, usually it relies on a physical medium. So such as we may use wire, we may use air. For example, Wi-Fi use air, right? And the Ethernet use electrical wires. And nowadays you may have heard of Google Fiber, so they use fiber. Actually, some people are also trying to use water as the medium now. Basically, as you know, 71% of the Earth's surface is water, right? If we can use water as a media, then it may be very helpful. Okay, for the medium, to select a physical medium, we have some technical and economical considerations. For the technical, basically, we need to figure out the bandwidth it can support. Bandwidth, that means how fast data can be transmitted over the medium. So nowadays, we are using, most of us are still using 4G, right? But with the introduction of 5G, the download speed is declared to be 0 gigabyte every second. So it's very high. And also, to select a physical medium, we also need to think about the economics, right? So although the wide cables are very reliable and they can provide very high transmission speed, but as we know, it's very expensive to deploy wide cables everywhere, right? And also it's very inconvenient. So you don't want to have many wide cables that go around your house. Instead, you would like to use Wi-Fi, right? Although it may not be as fast as wide cable Ethernet, but it's convenient. So you may have a question so for the figure here, so A is connected to B, B is connected to C, right? So how do A and C communicate with each other? So here we have the technique called hopping. Anyway, when direct communication between two nodes over physical medium is not possible, network can allow for these devices to communicate over a number of hops. So in this illustration, we may think that for A and B, it's 10 miles away, and B and C is 10 miles away. And for the medium, and also the protocol means Wi-Fi, cellular, something like that. Basically, the communication standards. Okay, for the protocol, it may only support 10 miles, right? In that case, A and C are too far away. So we need to do some hopping using B. To achieve this, nodes of a network must have awareness of all the nodes in the network where they can communicate. So to do this, we need to have knowledge of a route to communicate between nodes and that do not have direct links. To achieve this, we need to have IP addresses and the runtime table. That's what modern computer networking is using. Beyond the basic capability of transfer data, we also have some requirements for the speed and accuracy, right? So for the speed, most of the time we use the bandwidth to indicate that, okay, my mouse just went crazy. And accuracy, as we mean, so for example, transfer a sentence to you, but if you receive a disordered sentence or something we cannot understand, then the accuracy is not good. So basically for different medias and different protocols, there will be different accuracy and speed. And for this illustration, it's kind of the most simple, the simplest network. But for nowadays, we have complex heterogeneous network. Heterogeneous means that different types of network are there. For example, we have the Wi-Fi network, we have the Ethernet network, and we have different things mixing together. So for these few slides, it illustrates the complexity of now for the current network. So it will be left to you. Okay, now coming to the two terminologies you need to know after this class, after this course. We have the LAN and we have the WAN. LAN stands for local area network. Local area network. On the other hand, WAN means the wide area network. So as its name indicates, LAN was traditionally distinguishable from WAN based on the geometrical coverage requirements of the network and the need for third-party infrastructure. So basically, LAN stands for local. Basically, it's the communication distance is shorter. For example, for the Bluetooth, it may work well within your house, but if you take your device out of your house, so it may lose connection if it goes too far away. On the other hand, WANs provide communication links that cover longer distance, such as across metropolitan region, and you can also, if you use satellites, you can also cover the whole unit, the whole Earth. So in practice, WANs are often used to link LANs and metropolitan area network. So this is an illustration. So for example, a LAN is, you can consider it to be the university network, and also you can consider it to be your house, right? So you have many devices connected to the router, and WANs are basically used to connect these LANs here, and also the metropolitan area network. Basically, it covers the whole. And quantitatively, LANs tend to cover distance of tens to hundreds of meters, and WANs tend to span tens or hundreds of kilometers. So that's a general idea for you. For the WANs nowadays, especially for the scenario of IoT, so people are developing low power WAN. So low power means it does not consume that much energy. So this requirement is increasing in recent years, because traditionally, in order to cover large area, wide area, ideally, so we need to use more power so that the signal strength is strong enough to cover long distance, right? But in order to reduce the power consumption, people are developing low power WAN technologies. So we'll mention some of them later in this chapter. Okay, for both LANs and WANs, we can implement as wired or wireless. For the wired LAN, it is the Ethernet, right? Basically, if you look at a computer in the university, usually it is plugged in with a network cable, right? Usually the cable may be blue or maybe gray color. It will be inserted into a port in the computer or on your laptop. So that's the Ethernet. And also Wi-Fi is a wireless LAN and wireless WAN. So a good example is the cellular mode. These are just some intuitive impression for you to know what they are. And An intuitive example of similar device is wireless access point, commonly found in homes and offices as the gateway. So we have the wireless router, basically connects the Wi-Fi, and the DSL, basically digital subscribe line. So if you look at your router, so you will see that it needs to have a cable, wireless cable, not wireless, network cable that is connected to something called modem, right? Modem basically is another box provided by the internet provider, for example, the AT&T, the Time Warner, and it's called Spectrum anyway. So that's a setup. And also in the office, the Wi-Fi, we also have the Wi-Fi there, and then the Wi-Fi, the router will be connected to the corporate LAN. Basically, that's another way to connect. So it is worth expanding the consideration of WAN and LAN to encompass the idea of WAN, WPANS. When we mentioned somewhere ahead. Okay, it's here. WAN is personal area network. Basically, it is because it's personal, right? In that case, it is the distance is not that long. So if it is to provide low power, low rate network, so the protocol corresponding to it is 802.15.4. So that's related to the WPANs. So do you remember what it is? 80.211. So that's Wi-Fi, right? So these are just a few protocols you should know. And also, as the technology is advancing, just like the boundary of basic and advanced devices are sometimes overlapping, the boundaries of LAN and WAN technology, sometimes they can overlap. For example, for Wi-Fi. So Wi-Fi, you may think it is used in-house, so it is more close to LAN, right? But now with new protocols of Wi-Fi, it can also cover quite far away. So it is moving towards WAN a little bit now. So here we also list some examples of advancing technology. So now let's come back to the IoT network. So it will include a variety of wired and wireless technologies. Let's illustrate it here. So just to name a few, Bluetooth, you know it, right? So the WPAN we mentioned just now, and actually based on it, it comes out a lot of variation or some adaptations anyway, and also wireless and bus, point line communication, something like that. So yeah, also we should include Wi-Fi somewhere here. But anyway, just some examples. So if you look at figure, you see that we have the 4G, 3G. Oh, this is too old for you. This is 5G. And also some other methods. Okay. Yeah, for the IO, just some reading. For the Internet of Things, actually this term comes from RFID. So basically it is a radioactive tags that is attached to the items. So this idea was quite popular maybe 10 years ago when I was doing my master degree, but later people extend the idea to involve the sensors, actuators. So, but just a brief history of Internet of Things. Okay, so by this moment, we give an overview of the WANs and the LANs. Now let's look then into more details. Basically, we want to look at their features and some typical examples of each category. For WANs, it's typically required to bridge a capillary network to the backhaul network. So thus providing a proxy that allows information to traverse heterogeneous network. So for example, for the Wi-Fi network in your house, it is a capillary network, right? But if it needs to be connected to the internet or connected to the city, the metropolitan area network, so you need to use WANs. So this is seen as a core requirement to provide communication between cloud-based IoT devices and physical deployment of devices in the field. And it needs to have bi-directional communication, and it is achieved using an IoT gateway device. So there are a number of candidate technologies to select from for the wireless, for the wide area network. So some typical technologies include cellular network. You know that very well. DSL, we mentioned a little bit just now. Basically, that's what the internet providers are used. For example, AT&T and Spectrum, and Wi-Fi. So Wi-Fi actually can cover quite a large area. So it can be considered to be WAN. You can add a quote here. And Ethernet and satellite. So all of them will use the IP to deliver the information. Especially for the Internet of Things applications. So we would like to introduce the, well, my mouse is not working. We introduced the low power wide area wireless, low power wide area network. This is needed for the many IoT applications. For example, if we want to monitor the temperature of the ocean within an area, for example, we will have some devices floating on the ocean, right? In that case, the distance are quite far away from the antenna, so it is wide area. And also, we don't need to record the temperature very frequently. For example, we may monitor the temperature maybe only every 1 hour or every 1 day. In that case, the data transmission overload is very low. So the main consideration here is to reduce the power consumption, right? Because those devices, when they are floating on the ocean, it's difficult to charge them, and it's sometimes difficult to locate them by sending people to pick them up to recharge, to change the battery. In that case, we'll try to make them use less power as possible. So that's a developing area for the IoT network. So there are some standard bodies. Basically, they are developing their technologies for the low power wide area network. Here we just cover some of them. The idea is that basically you have some impression of this term. So later on, when you read about this in other works, so you have an idea to know that, oh, it's one of the low power wide area network technology. Okay, basically the low power wide area network is a broad concept, right? But to implement this function, we need to use specific technologies like NB IoT, LTM, and in long term. Basically, the requirement here is just that when you read about this terminology somewhere in the future, you know, okay, it's one of the low power wide area technology. Okay, and also when later on, if you work on the project, you need to deploy a solution to a problem. Then these are the inventory where you can find your communication technologies. For example, if your solution need to use low power wide area technology, then you can refer to these technologies, and you may also do some comparison of them to pick the best one. Okay, let's keep going. So Sigfox, LoRa. So LoRa, actually I think it's leading in this area. Many companies are using it actually, and also some other ones. Okay, and for the standards, so IEEE is doing something, ETSI is doing something, and some organizations are doing something. So LoRa is an alliance. So in the last unit, we talked about that the standards can come from the standardization organizations, can come from the alliance, and can come from an open source project, right? So LoRa basically comes from the alliance. Okay, after talking about the wide area network, now let's come to the local area network, right? The term LAN originating from the internet topology and often certain type of access technology. So in the IoT scenario, so local area network, usually it is referring to capillary network. For such a network, it should be autonomous, self-contained. It should be deployed in a controlled environment. And there are actually numerous capillary networks nowadays in the world. So for example, every house, I believe, as long as you have Wi-Fi, it is a capillary network. So basically the whole scenario is just like this. Okay, so we have a gateway or access point. Usually it is the Wi-Fi together with the modem. Okay, and then you have sensors connected to the gateway. You have sensors connected to the Wi-Fi, connect to access point, then go to the Ethernet. So basically, this is a capillary network, and all of this can be connected to the core network or the internet or the cloud. Basically, that's the world. Okay, so that's the relationship between all these items. For some application areas, there's a need for autonomous local operations of the capillary network. So basically, that can be deployed on the gateway device, as we mentioned earlier. The IoT devices in a capillary are typically thought to be low capability nodes, because what? Because we want to save the cost, right? And they should operate autonomously. And for this reason, a gateway or an application server will naturally also be part of the architecture. So in that case, let's come back to the figure. In that case, we need to have something like this to be connected to the world, gateway or application server. For IoT, they may be using a IPv6 protocol, and they will use this communication method. So 6 LOWPAN. So can you figure out what it means? So 6 means it's using our IP version 6. And low means low power. And the wireless personal area network. Okay, for local area network, some typical technology include the ZigBee. ZigBee is based on this one, okay? It's based on this protocol. And also we have Bluetooth and Wi-Fi. This may be the 3 most daily technologies used in labs. So basically, for the deployment of LAMs, the nature of the intended application plays an important role in determining the appropriate technology solution. So that's easy to understand. So you may. Okay. Now let's come to the key technologies for the LAMs currently and under development. So we have the PLC, basically is communicating over power lines. So it has numerous flavors. It's used for remote metering and maybe for smart grid. So PLC. And we have the LAN, especially the Ethernet and the Wi-Fi. So those are the 2 protocols. And we have the Bluetooth. So it's short range and it is high data rate. It's a low cost and energy efficient. And we have the low rate, low power networks coming out based on this protocol. Yeah, which we mentioned many times. So the full name is low rate wireless personal area network. Yeah, seems like. Okay, it is it's the base for ZigBee and many other things, and also for the 6 low WPAN. By the way, actually, when we say it is low rate, so it's not that low, okay? So it can come up to 256 gigabyte per second. So it's not that low. You can still, maybe it's too low for watching a video, but it's quite reasonable for transmitting other information most of the time. And for this one, that's what we want to highlight. So 6LoWAN, basically it stands for, anyway, it's quite long, but it's just an abbreviation of it. Okay, so I should not, so this is a typo here, so I just want to italic this part, but it is not an important part, just some expanding reading, okay? And another key technology for LAN is the RPL. It is called IP version 6 routing protocol for low power and lossy networks. So this is also getting more important. Low power means that it can save energy, and lossy network basically means that during the transmission, some data will be likely to be lost due to the environment or due to the distance. So they try to use this technology to handle such kind of scenario. For example, later in the future, if we are traveling to the space, so basically the spaceships are quite far away from each other, and there are many planets and stars in between, right? So we want to have something that can transmit the data within such environment. And we also have the COAP. So it is just using a simple request and response interaction model. Basically, I would just send a request to you. For example, I want to get something. So from A, I send this request to you, and then B will get this information and then send the data to me. So it's just like simple talking. Okay, so this video covers some basic WANs and LANs technologies. So basically, we talk about how they are different, and we cover some key technologies in each category. So the requirement is quite simple. So you need to know the difference of them and know about some key technologies in each of them.